Welcome to Drone System and Control course. In this particular lecture, we are going to talk about autonomous drones. In the previous lecture, we talked about previous modules. We covered about navigations, we talked about sense and avoid, we talked about local planner, global planner, and then we also talked about control architectures and all this. This lecture, we just cover how we can operate the drones in autonomous fashion. Before we go into autonomy, we'll talk a little bit about why do we need autonomy, what level of autonomy we need for different applications. We try to understand the autonomous aspect, some hierarchy present in the autonomy, how the hierarchy is there, where it will be useful, what are the different levels of autonomy, how the human effort is decreasing when we increasing the level of autonomy, then what are the critical technology required for autonomous operation of these drones, and all this will be covering up. Finally, we touch base on moving from solo autonomy to a group autonomy. When we have a group autonomy, how the different levels present in different group autonomy, and what is the highest level, and where, for what kind of application it is needed. Okay. Now, when we look at autonomous areas vehicle, we know that we've been using drones in variety of applications coming from agriculture. Agriculture, when I say precision spraying, monitoring, soil health monitoring, crop monitoring, production assessment, we can use it in different purposes, right? Industrial inspections, it could be building inspection, it could be infrastructure inspection, or it could be for logistic purposes, or it could be for defense, search and reconnaissance kind of a mission. The biggest challenge when we are using autonomous areas vehicle, operating challenges is what we need to look at. Of various operating conditions, safety is a critical factor. Safety of the payload which is being carried, or safety of the environment where the drone is operating is very important. And we also have to understand, wherever we are operating these drones, the environment could be cluttered. Let's say if you are doing inspecting industrial building or industrial applications where you are doing inspections, you may have to fly where the obstacles could be present. The obstacle could be a building itself, or it could be a pole, or it could be a wire, right? Power lines. These are going to be an obstacles for us. And it could be an between buildings you may have to navigate, right, if you are talking about warehouse kind of an applications. So cluttered environment where it is going to operate, so their safety is one of the important aspect. The other aspect, when we talk about logistic operations, longer distance it has to go. When you go for a long distance, the terrain variation is going to have significant impact. Of all these challenges, two aspects that I just put, privacy and security, is one of the important aspect we need to look at. Whatever the sensor we are carrying, that should never capture something which is not supposed to be captured. Security should be taken care. Safety, privacy, security are three important challenges when you are operating autonomous aerial drones, right? There are incidences, right? The drones has been flown inside the Saudi Aramco oil facilities and started creating disaster scenarios. In some places, it's just started flying in the path of the, in London Heathrow Airport, some of the drones are flying in the path of takeoff, right? It's delayed the takeoff of the aircraft, which in turn delayed all the air traffic motion on that particular day. So we have to take care on those aspects also, right? Now, let's take a scenario of what we call surveillance aspect of it, right? When I talk about it, you have a multiple drones flying. These drones can just go and escort some of the vehicle which is going in unknown, uncertain terrain, or it could also look for searching survivors in a disaster stuck environment. It could be like flood kind of a scenario, or even earthquake kind of a scenario, or even for search and rescue mission for missing people when they are going for hiking due to so we can use these search rescue mission in various scenarios, right, where the objective, the mission is not like what we discussed in module 3 when we talk about we define the waypoint, you just go to that particular waypoint and come back. Here the mission is to search for something which is there in a specific region. If you think about a forest fire is just one bigger issue in the world, right? It could just appear randomly and they can just distribute. The fires cannot be neutralized by the single drone. You may need a multiple drones to operate. A single drone trying to quench the fire may not be sufficient. There should be a cooperation needed, coordination needed, so that they can extinguish the fires properly, right? The task that they are performing is really complex, right? How the drones interact in the environment to make the decision is very important. Here the drones are interacting with the environment to neutralize the fire, right? How they are going to do it? They have to make a decision. A human cannot say, okay, you go from clockwise to anti-clockwise, he will go from anti-clockwise to anti-clockwise direction. It's not possible. They have to make decision based on the size, which is unknown, right? The location of this fires is unknown again. How many fires are also unknown. They need to detect, localize, decide who will do. If more than one needed, which ones will come together. So those decisions they have to make. That's very important, right? How they interact with another autonomous drone is also important. For example, I see a target, but another drone may not see a target. Now when you say we have to cooperate together, how will I cooperate if I don't see a target, right? That's going to be a real challenge. So how they make decisions to come together to execute such a complex task of neutralizing forest fire, right? This is where autonomy is needed, where human intervention has to be minimum, where the drones are capable of making decisions, right, and executing such a complex task, right? Now, when we talk about these kind of problem, the following question comes to our mind. If I want to do such kind of complex task, what kind of technology I should have in my drone, right? The second question will come, what is the level of autonomy I need, right? Then third one going to be, how am I going to make a decision in an uncertain environment? Most of these complex environment tasks are uncertain, right? How am I going to make a decision? The fourth question comes to us is how to work together in a group. That's the biggest challenge. So in a large area, if you have a communication infrastructure, then you can say I can ask for one more drone to come together. But if that drone sees another fire, how am I going to act on it? Whether I am going to neutralize the fire I am seeing or neutralize the fire which is being identified by some other drone, right? So that's going to be that's where we need a new technology or an algorithms to be built such that these drones can operate in autonomous fashion to execute complex tasks, right? Now, what is the technology required? Let's talk about algorithm, let's talk about software side also, right? What are the algorithms? I need to be aware of my missions, right? I need to have the capability to plan and operation in complex environment, right? Mission awareness is the critical. What I meant is, let's say a larger fire. Larger fire, if you leave it, it will spread much faster than a smaller fire, which means the impact it will create on natural environment is much higher than a smaller fire. So now the question need to be answered, can I neutralize the larger fire before it becomes uncontrollable, or can I look at multiple small fires? The decision need to be done dynamically. And awareness here is, I want to minimize the impact, right? Ecological impact on the forest. So how do I handle that? That's also an important, right? Mission awareness for their planning and operations. That's the first, we need a new algorithms. They need to have a learning capability, because this is an uncertain scenario. We cannot go ahead with the fixed rule books, right? they should have a ability to adapt their operations and plan on real time, right. That is what I meant as the third point, is real time planning and operation is needed. The fourth one, learning based models, basically they empower these drones to make decisions, right. So we need some algorithmic development also, but that is not alone sufficient. Of course we need hardwares to detect these targets, right. The technology, the compute capability should be there, the sensing capability should be there, right. Those are hardware requirements. But there is a software requirement is very critical here. I need a real time system. Real time systems can schedule and allocate the resources appropriately, right. When I say resources, the resources in computing, resources in hardware also. Let us say I have a downward looking camera which I am using it for flow measurements. I can use the same camera for object detection also. When do I switch the role of this particular sensor for different purposes? That resource allocation need to be done in real time, right. Resiliency is needed. Resilience in cyber architecture for autonomous drones. Why? I do not want external interference which affects my decisions. I have to be resilient against external attack. External attack need not be on the software level, it can also be on the sensor level. So I need to have a reliability in my algorithm so that my detectability with high reliability is needed, right. Security. Cooperation in cooperative operations, when it comes into picture, I can share my sensor, what I meant is the output of the sensor, or I can share my processor, right. I can do that. How do I handle this cooperation? Cooperation within the drone, across the other drones also, right. Self as well as collaborative. And autonomous negotiation capability. Suppose I should have an ability to assign a task to other person, right, or I have the ability to take the resources for a specific purpose. That negotiation ability also need to be enabled such that autonomy can be employed in these drones, right. Now let us look little detail. Some of these are recap from our earlier lecture when we talk about sense and avoid. We need autonomous drone, that is very clear. We need them for all these complex task executions. What I meant is they need to be fly on their own, right, based on the mission or the information that we are given in the beginning. They should have the ability to adapt and react to the threat. They have the ability to sense the evolving situations. For example, the fire, if it is growing bigger and bigger, they need to know in what direction the fire is expanding. So they need to change their trajectory in such a way that they can mitigate the fire, right. They need to know how to collaborate or how to cooperate between themselves such that the overall mission is successful, right. This is very important, right. They should be able to do repetitive tasks with the high precision task require automatic systems, right. So what I meant is, suppose I want to go and deliver a payload to a specific location and come back. I want to repeat this in high frequency. I need an automatic system, right. I am just bringing the word here. High precision automatic system is good enough. But the same when I am going to drop, the environment where I am going to go and deliver the payload is going to change in dynamic sense. Suddenly there is a procession and then my pathway need to be changed. I should be able to make my decisions, right, and plan in dynamic fashion and learn to understand what is sensitive and navigate. Then I need autonomy, right, capability of making decisions with minimal human interventions or with just only human observation. So that is where we need autonomous drones, right. Now let us look at little bit more details. What is the advantage of such autonomous drones? they can operate continuously without human intervention, or what we can say, the effort from the human is going to be decreased significantly. Human will just become an observer. He will see whether everything is going as per the mission, right. So, which means one person can handle multiple drones, which reduces the significant human cost, right. And these drones should have the ability to sense, and the ability to learn, and the ability to adapt to the evolving situations, right. Again, very interesting philosophy. What it has to learn, how it has to learn, and when. See, what, when and how is very important aspect. So, that characteristics should be present in autonomous drones if you are talking about highest level of autonomy, right. We will talk about different levels of autonomy there. It will be clear for you what I am trying to say, right. All these I am doing for what? Improving the performance or improving the efficiency of operations over time, right. Over a time, I am doing multiple missions. I should be capable of doing that mission much more efficiently, or I should say more accurately over a period of time. But there is a challenge. Such kind of autonomy, highest level of autonomy, require high cost. Not just the cost, safety is also a concern when they are trying to make decisions, right. How safe those decisions are is very important. These are some challenges comes into picture, the trade-off between cost and safety of autonomous systems, right. Now, let us look at different functions of autonomous system, right. Autonomous drone, what I meant here, right. Autonomous function is the key, that is the central part, right. It starts from the basic control module, low level control. First, the drone need to be stable. It has to track the trajectory as accurately as possible, right. The trajectory tracking characteristics, whether you give a position, a waypoint, it has to follow the waypoint precisely. That is the control module have to take care. The navigation module have to generate the trajectory, right. This navigation module requires a waypoint. That waypoint will come from your planning module. The planning could be global planner or local planner. When the situation is changing, the local planner need to generate the modified waypoints, and those modified waypoint will go on to navigation module, right. Now, when do I change my trajectory? I need to make decisions, right. For example, if I am traveling from point A to point B, suddenly the situation changing, I started seeing increasing traffic, which means a lot of drones are crossing me. I need to find out which is the drone crossing, which one is going to be a potential threat. If I identify the threat, and then I have to look at the threat location and the time. Based on the location and time, I need to pass on the information to my planning module which generate the trajectory. The trajectory should be a feasible trajectory which can be employed to avoid, right. Or the threat is very close, then I may have to take a different decisions, and for those decisions my planning module have to work differently, right. So, there is an interlink from decision module to planning module, right. But to make decision, I need observation of the situation which is evolving over time. I need a perception. This is again challenging, right. Not all sensors going to be good for all conditions, no free lunch theorem, right. The sensor that I am using should be able to sense the environment, and I should have an algorithm which can detect the evolving scenarios, pass on to my decision module, right. But I can detect, but I need to know where am I. Where am I is very important to make all the decisions, right. Localization is also very important. You may have a GPS sensor, suddenly the GPS is not functioning. We often see when we are driving a car in a cloudy day, right. We can see that the car is shown not in the road, but at least some 10-20 meters away from it, right. It sometimes will be showing on the top of the building too. Suddenly it will be spanning the car in next road and will asking us to take a U-turn, right. Localization is also very important. Localization says where you are. Based on where you are, your decision will differ, right. So, there is an interconnection between all these modules, right. Whatever the decision it makes, whatever the planning it does, how it is navigating it, the control module have to execute, right. Overall, the autonomy should enable safety, security, and the decision that it makes, it does not violate the privacy of individuals, right. So, all these need to be taken into account. But we are not going to talk much about privacy aspect of it. We are not going to talk about security aspect of it. We will focus more on technology aspect of it. Okay. What are the technology that we need to develop so that we can achieve certain level of autonomy in this course. Okay. Let us look at flow of autonomy of operations, right. What happens? I have the environment. I have a sensor in my drone which is looking at a perception aspect of it, and then it extract the information from my sensor. It is not only an external environment, it is also localization takes place here. I am trying to know where am I am trying to understand my scenario where I am present, then I am trying to put it in my map. Say this is a scenario, this is where we are, right. From there I have to make decisions. Is that object in front of me is a threat, is going to be a collision alert, or it is just going to cross, so I do not need to worry about it, I just need to track while I am moving forward against my towards my goal, right. So, the decision need to be made, or is the target, I need to lock on to the target, continue to track, or is this the fire, then I need to change my trajectory. That kind of decision should take place in this particular block. Once the decisions are made, you need to plan, you need to navigate, and that will generate a trajectory that will go to flight control module. The flight control module sent to actuation, and the actuation will just make some change in the environment, and again your sensor will perceive. This is the flow of our autonomous operations we are looking at. Now, let us try to understand different levels, different hierarchy of autonomy, right. Before we move on to the level, there is something called strategic, right. It is a low frequency. It tries to interact with the human on the mission, right. It performs some kind of a cooperative search looking for the target. Once you identify the target, it sees whether the target is static or dynamic. Based on that, what kind of allocation needed, who need to go. It could be one on one or one on many. So, many drones acting on one target or one after other, that kind of decision need to be taken place, and they have to do, who will do that, all this allocation will take place in strategic level. Once a task is being allocated, based on the mission, it has to generate the path. So, mission awareness in path planning is also needed. These are low frequency in autonomy. There are low level decisions which happens at very high frequency, right. For example, localize, where am I, right, what is my map, right? How I am observing things, and I have to map it back into the in my world where I can take decisions, right. If I see there is a threat which is going to be an obstacle for me, how do I avoid? How do I generate a trajectory which is feasible? Those are like high frequency decisions that I have to do. There are something called tactical, which is a medium frequency. If you detect a target, you have to track it. If you see something, you have to cooperate on task execution, then you need to do that. And for that, you may have to generate a trajectory, and you may have to share your information with your neighbors so that you can cooperatively execute that task. These are tactical level, right. Once we see a target, or once you see someone, your neighbor, and you want to share the information so that we can maximize the mission of the whole team, right. Those are tactical. So, you need to understand the autonomy require actions. Those actions are at 3 different levels: high frequency levels, tactical level, and strategic level. right. So, these are different levels in which these decisions take place. Now, let us look at level of autonomy. Level 0, right. Level 0 means what? The drone or the autonomous aerial vehicle is completely controlled by operator. It does not make any decisions. In fact, it does not even have stability augmentation inside, right. It is pure manual flight. It's sometimes we do it in a hobby flight, right. We have small drones, we just toy drones are there. There is no control as such, right. It's 100% operators, which means 100% operator needed, which means human effort is 100%, machine effort is 0. Level 1 autonomy. There is a computer, the computer takes care of the stability of the drone, right. Make sure that any environmental disturbances, the drone is stable, but operator control the rest. So, the level of human effort decreases, the computer effort increases. In level 2, operator responsible for safety of the drone, computer takes care of the stability, heading and altitude. It is typical autopilot which is present in the drone. You give the waypoints, once the waypoints are given by the operators, the computer takes over, right. Operator just monitor the safety of the drone. In case if there is an emergency, operator take over, right. Level 3, operator is a fallback, right. He just stays there. Computer control all the functions at nominal conditions. Everything is nominal operation conditions. Computer takes care of the most of the tasks, operator is just an observer, right. Level 4. In level 4, a computer makes the decision, but operator just approve, okay, fine, go ahead and execute, right. That is a level of autonomy. In level 5, computer will inform the operator that I am going to do this, right. Approval is not needed, right. So, still you see here the human presence is there at level 5 autonomy, human is just an observer. The cognitive workload, if you look at level 5, it is very minimal, at level 0 it is 100%, right. So, that is what I mentioned here. Level 0, the human computer does not have any role, whereas level 5 computer takes care of the full. So, full autonomy, full solo autonomy means you have to reach level 5, right. Now, let us try to understand what this autonomy, whatever we are saying in terms of technology which is required, algorithm that what we want to build. Level 0, there is none, we are not talking of any algorithm needed. In level 1 and 2, I need to, the flight controller need to take care of stability, position and velocity tracking, but at the same time I have a sensor which can sense the environment and alert me, right. Here I am talking about simple sense and avoid kind of a scenario, right. I can sense the obstacle, I will alert, I do not know what to do. Now, the human operator comes on board when in this scenario, he will take care of the safety aspect of the drone, he will avoid the obstacle and again bring back into autonomous mode, right. So, level 2 is like that. Moment you go to level 3 and 4 is more like a conditional aspect of it. I can sense, I can avoid in a nominal conditions, right. In level 4, I will inform the operator to get their approval before I execute. Level 5, I have the ability to make my own task. When I am flying in a swarm, I can identify the target, I can tell another drone I am going to take this target and I will move ahead. If I have to cooperate, I will understand whether we have to go in a circular motion, then I will keep a minimum distance between these two drones so that we can operate in a circular motion. I can get into any formation flying based on the task. So, I will be able to make such kind of decisions, generate the trajectory and dynamically apply the trajectory to get the mission success, right. So if you see, the level of computer function goes from 0 all the way to 100%. The human cognitive load for a level 0 it is 100%, it goes down to very small percentage when it goes to level 5 autonomy. Right? Now let us understand different levels of autonomy and what is needed, in what applications such kind of levels are required. Level 1, operator is needed. Operator control most of the functions, right. Basically the flight control architecture or autopilot does some vital control functions for short period of time. It stabilizes the drone, right. It also helps to sense the vehicle state and send to the operator. It says this is the current velocity in which I am flying, this is the altitude in which I am flying, right, and these are the GPS signals I am getting, or if the communication is going low, if the battery is going low, I will just inform the operator. I do not make any decisions there, right. Operator control most of the velocity and positions such that the drone can perform a certain actions preferred by the user, right. So you can use this for hobby flying or photography kind of applications. Level 2, operator just responsible for safe operations, right. He monitor the airspace, he monitor the flying conditions, and he provides the waypoint, and rest of the things taken care by autopilot. Some vital controls, navigation functions like auto takeoff, landing, navigation, everything is taken care by autonomy, right. Application could be mapping, survey, agriculture spraying. Here, in addition to normal trajectory tracking and position, it will also sense the vehicle state and collision alert. If there is an obstacle, it detects, it just says there is an obstacle. Level 3, operator is a fallback option, right. Means he will ready to take control only when he gets an alert. Otherwise, he will act like an observer, right. Most of the vital functions, navigation functions taken care by the autopilot, sensing is taken care by sense and vehicle state, and collision alert taken care by autonomy. Again it is used for mapping, survey, delivery of payloads from one point to another point, use it for surveillance purpose, fixed surveillance purposes, right, perimeter surveillance, or you want to do a border surveillance, right, or looking at inspection aspect of it and periodic inspection aspect of it, you can use level 3 autonomy. Level 4, only for monitoring purpose, right. Operator is only for monitoring. All vital functions, sense and avoid is taken care by autopilot, and whatever the decision control board you are providing, they will take care. You can still use it for hobby flying, photography you can do, inspection you can do, delivery you can do, surveillance you can do, mapping you can do in level 4, right. Level 5 is a complete autonomy. But one thing to note, in level 5, the drone need to interact with other drones in the picture, right. Up to level 4, if you look at, the interaction of the drone is limited with respect to the operator, right. In level 5, you are bringing the highest level of autonomy, where the drone is able to make its own decisions, it is able to learn to make decisions, improve the decision making capability, and it brings in the aspects of cooperation among others, coordination among others to perform certain complex tasks like firefighting, search missions, search and reconnaissance missions, those kind of aspect, right. Now, moment we bring those aspect of it, it is no longer solo autonomy, it becomes a group autonomy. So let us project it from the group autonomy perspective. The levels of autonomy going to be from 0 all the way to 10, right. RPV mode is a remote piloted vehicle, is a continuous command is what I am looking at. Here the definition changes slightly with respect to the level of autonomy that I was presented earlier, right. Level 1, 2, 3, all these we call it supervisory command link. There is an operator, he will more like a supervisor there in level 1, 2 and 3, right. Whereas when you go to level 4, a discrete communication link. I am still an observer, I will act only when there is a safety aspect comes into picture. Otherwise, the drone is capable of making decisions and keep informing me about its actions. Moment it crosses the level 4, the autonomy, the full autonomy of a solo drone is required to enable the group autonomy characteristics. If I am talking about coordination in centralized setting, there is a central agent which will look at all those drones and then their decision will take place, and that setting if I am talking about level 5, 6, 7 where mission initiation will take place from command. Moment mission is initiated from the command, these drones can cooperate, coordinate among themselves to perform missions and execute the missions, act on the environment in a coordinated fashion, cooperative fashion to maximize the benefit of the mission. The highest level if you are moving, right, but scalability is a problem, single point failure, right. Moment you move from centralized setting to decentralized setting, you initiate the mission through command, but there is no leader, right. Everyone is independent, more heterogeneous setting, right. They take decisions, right. If required they cooperate among themselves. If you talk about swarm of drones, when I say swarm, a group of drones within a radius R, they are independent, but they function in such a way their behavior solves such a complex task, right. They may be homogeneous or they may be heterogeneous. Based on their capability, they are able to cooperate and they will be able to decode a complex task into multiple simple tasks, and they have ability to assign the task, adapt for different tasks, right, and that kind of setting is completely scalable, which is level 8 and 9. Level 10, highest level, right, I have heterogeneity. I can communicate with the satellite, I can communicate with the decision layer, I can do combat operation, I can do tactical operation, I can interact with, inform my mail, hail, right, all those can combine together, execute such a complex missions, right, which requires highest level of coordination and cooperation. If you see level 0 to 5, communication aspect is not there, level 0 to 4, right, except the communication happens from the autonomous drone to the mission computer or the operator, just information sometime for command to take care. Moment you come to level 5, there is a communication between them. They need to decide what to communicate, how to communicate. Shall I send the entire sensor information, or shall I send my decision information, or shall I send my map to him so that we can make decisions which is beneficial for the group, right. But again there is a central observer here. Moment you go to the highest level of autonomy, it is completely scalable. They can do any complex task, they can coordinate among themselves, they can share information among themselves, they know how to manage themselves, right. That is the highest level of autonomy. Here 5 all the way to 10, communication aspect comes into picture, right, and their ability to function as a group comes into picture. That is why it is called group autonomy, other one is called solo autonomy, right. So when I say remote piloted vehicle, or it could be guided vehicle or autonomous UAV, so we can just bring in setup where they can just, there could be multiple groups they can interact, right? So that's the level we are talking of. Now, what are the key technology needed for this autonomy? This course will not talk much about the group autonomy. Probably we'll try to spend one lecture to talk about how task allocation can be executed at the highest level, right? That's level 6, or maybe in some part of level 9, right? We'll talk about it. But most of the lectures going to revolve around how we can handle the situations, how we can allocate the control task when there is a GPS is not there, when there is a communication is not there, when the situation is keep changing, how do we extract the information from the scene and which we can use for localization, mapping and sense and avoid kind of a task, right? High frequency, low level decision task, right? To some extent, the mid frequency tactical task of threat detection, task allocation, adaptation, cooperation and coordination will touch base, right? When we want to do all of this, we need two simulation system needed. One is a software in loop. I can validate how good my software is it operating in real time, and I can do it in hardware in loop to see whether the communication take place from different module to hardware in real time, right, or near real time. So because the moment autonomy comes into picture, different level in which the loop will be closed, right? When we talk about flight control, we discuss this inner loop, outer loop, right? This will be outermost loop. This frequency will be different based on different complexity level, right? The high frequency load decision will operate in certain frequency, whereas the medium frequency will operate much lower than that, and strategic low frequency decisions will happen much lower time scale. Now we need artificial intelligence. AI is very important when we talk about autonomy aspects of these drones, right? We may touch base some about of, sometime we may need a fully connected neural network when we talk about GPS denied operations, when we talk about sense and avoid kind of an applications. We may need convolution neural networks when we talk about threat detection, tracking the threat, understanding the situation, context in which the drone is flying. So we may need a convolution neural network. We may need reinforcement learning when we are talking about what is the rule that I need to bring in for the current situation. How do you find the policy which maximize the benefit of the operation, right? But in this course we will not be looking at reinforcement learning. We will try to give a quick recap on fully connected neural network and touch base on how this will be useful for detecting the target, right? Estimating the location where obstacle is going to be there, or collision alert, spatial and temporal location estimation, we will discuss about it. How we can use the fully connected neural network for GPS denied navigation purposes, we will talk about it. We will also touch base on quick recap on fully convolution neural networks. We call it for visual analysis to find out the threat identification and detection and so on, right? But to do all of this we need a software simulator. The software simulator should be integrated with my computer, right, so that I can understand the scenario in which it is flying. I should connect my remote control stick also so that I can operate, right. Here MATLAB runs the entire 6 degree of freedom model. The output can be sent directly to the drone which can just fly. I can get the environment, I can generate a different wind conditions, I can bring in different camera sensors, depth camera or monocular camera, I can bring in LiDAR sensors so that I can see model all of these sensors such that I can evaluate the algorithms whatever we are building, is it working in real time or not. Right? We need such software in loop simulators to validate the technology or algorithm what we are building. Okay. So, in this lecture we talked about autonomy. What's autonomy? Why do we need autonomy? Where we will use autonomous drones, at different levels of autonomy, different hierarchy in autonomy, how different modules present in autonomous functions interact with each other. Right? We also discuss about group autonomy, where the drones are capable of making decisions, working together, performing such a complex task by doing cooperation, coordination among themselves. Right? We also touch base on kind of simulation environment needed to validate the algorithm what we are building such that these autonomous operations can be executed successfully. Thank you.